Let's solve this problem together. Steam initially at 0.3 megapascal and 250 degrees centigrade is cooled at constant volume. So it's going to be a constant volume process throughout. So at what temperature will the steam become saturated vapor? That is the first question. Second question, when the temperature reaches 80 degrees, what is the quality? So what is the quality at 80 degrees Celsius? And then the third question is, what is the heat transferred per kg of steam in cooling from this 250 degrees to 80 degrees? So this is a very interesting problem. Let us write down what has been given. So we start with pressure 1. So P1 is equal to 0.3 megapascal. And the temperature 1 is equal to 250 degrees. First we need to find out in which state this particular state is in. In which state is in. Whether it is in a subcooled region or in mixed region or if it is superheated region. So what do we do for that? Let's go to the steam table. From steam table, let's see what is the saturation temperature for this particular pressure. So when the pressure is this value, at what temperature will it change phase? So when we see for P1 is equal to 0.3 megapascal, the saturation temperature is, I have the value here, the saturation temperature is 133.522. 133.522 degrees. That means when the pressure is kept at 0.3 megapascal, the steam will change its phase only when the temperature is 133. So for 0.3 megapascal, the saturation temperature is 133, but our temperature is higher than this. This is 250 degrees. So therefore, T1, our temperature is greater than the saturation temperature, which means the state 1 is in superheated region. It is already a vapor. It's in superheated region. So if we cool by keeping this pressure constant, if we cool it, only when we reach this temperature, it will start changing its phase. It will start changing from vapor phase to liquid phase. So since our temperature is greater than the saturation temperature, this particular state, the state 1 is in superheated region. So now what is the question? The question is, at what temperature will the steam become saturated vapor? First of all, let us find out what volume does this occupy in this state. So let us go to the superheated steam tables. Superheated tables. Because since this is in superheated region, we go to the superheated table. And for P1 is equal to 0.3 megapascal. And T1 is equal to 250. What is my volume? That's what I need to find out. So that's what I need to find out. My volume from superheated steam table is 0.79644 meters cube per kg. So this is my volume V1. The volume at this pressure and this temperature. Okay. What has been mentioned here? The steam is cooled at constant volume. That means this volume is going to remain constant throughout the process. That means our V1 is equal to V2 is equal to V3 is equal to so on is equal to constant, which is 0.79644 meters cube per kg. This volume remains constant. What is the next question? What is the first question? At what temperature will the steam become saturated vapor? He asks us, if I keep this pressure constant and I am reducing the temperature, at what value of temperature the steam becomes saturated vapor? What is saturated vapor? When we draw this, let's say TV diagram, it's going to look like this. So it's like we increase the temperature, increase the volume, and then it remains constant till all the water is changed into steam, and then temperature further increases. So we start at this point. We are in this region, superheated region. Then I start cooling it. When it reaches this point, it will start changing its phase. So this is the point of saturated vapor, and this is the point of saturated liquid. Now I am in this region. I am going to cool my steam. So he is asking at what value of temperature the steam will become saturated vapor, at least this point. So what is this point? We know that this point is Vg. So what are we going to do? We are going to go to the steam table. We go to the steam table and we calculate the value of Vg for the given value. So we fix this pressure at this pressure. If I just cool it down, no, we don't cool it down. What do? We cool it down. We don't know what will be the pressure and what will be the temperature. What are we going to do? We are just going to cool it down. But the hint that he has given is the volume remains constant. So if the volume remains constant, this has to be more volume throughout the process. Throughout this process, this has to be more volume. What is this point? This is the saturated vapor point. When something is saturated vapor, that means it is completely vapor on the verge of phase change position. So my V has to be is equal to Vg when it is saturated vapor. If it is in this region, it is Vf plus x into Vfg, or 1 minus x into Vf plus x into Vg. So that means when x is equal to 1, V is equal to Vg. That is my saturated vapor point. That is this point. So my V is Vg. So let's go to the steam table, and we go to the saturated steam table. Saturated steam table. We go to the saturated steam table. For the given pressure, let's list down the values Vg. So let's go to the saturated steam table for the given pressure. Let's say 0.3 megapascal. And when we go to the saturated steam table, we see Vg value is equal to 0.81598 at 123 degrees. So I have this pressure, I go to the saturated steam table and I go through the steam table and I am trying to find out the value that is near to this. So my Vg value is 0.81598 when the temperature is 123, and my Vg value is 0.79261 at 124 degrees. So that means my Vg value is somewhere in between these two. So the temperature at which it becomes saturated vapor will be somewhere in between these two. So what am I going to do? I am going to just interpolate it and I calculate for a given value of Vg is equal to 0.79644. My temperature is 123.837. 123.837 degrees. So that means when I cool down the steam, when the temperature reaches this value 123.837, my volume is equal to Vg. That means it has become the saturated vapor. So this is the temperature at which the steam becomes saturated vapor. That is the first part of the question. Now let's move on to the next part. He asks what is the quality at 80 degrees. I'm going to erase this. Remember, the volume remains constant. So he is asking what is the quality at 80 degrees. The quality at 80 degrees. How are we going to calculate the quality? Now the steam is, for the second part, the steam is cooled to 80 degrees. My temperature is 80. Okay. And also I know another thing, which is the volume. Volume remains constant. So volume is going to remain constant throughout the process. So my volume is 0.79644 meters cubed per kg. So these are the two things that I have now. So what am I going to do? I'm going to go to the steam table. I'll go to the steam table. Steam table, the temperature table of the steam table. Temperature table of steam table. And I'm going to see what is the value of volume at temperature is equal to 80 degrees. I'm going to the temperature steam table. I'm going to write down my VF value. VF value is equal to 0.001200290 meters per kg. So this is my VF, value of VF, the volume of the fluid portion or the liquid portion at 80 degrees. Because I know my temperature is 80 degrees and the total volume at 80 degrees is this. And then I'm going to write down what is my Vg. Vg value at 80 degrees is equal to 3.4052. 3.4052 meters per kg. And we know that Vfg is equal to Vg minus Vf, which is equal to this value minus this value. I'll get 3.40417 meters per kg. So I know what is my Vfg. We all know that the total volume is equal to, total volume V is equal to Vf plus x into Vfg, or you can write total volume is equal to 1 minus x into Vf plus x into Vg. You can write it, you can use both the formulas. I'm going to use this because this is more convenient. And what is my total volume? The total volume is going to remain constant. So the value is 0.796244. This has to be my volume because the volume remains constant. What is the value of VF? VF is equal to 0.0010295 plus x into x is what he is asking, the quality at 80 degrees. X is what we have to find out. What is the value of VFG? VFG is equal to 3.40417. So therefore, then plus x is equal to, I'm going to bring it to this side, so 0.796244 minus this value 0.0010295 divided by this value 3.40417. So therefore, I get my x value as 0.232. So this is the quality of steam at 80 degrees. Now what is he asking? He is asking for the heat. So I'm going to erase this now. Let's go to the third part of the question. This is asking for the third part of the question. He's asking what is the third part? Third part asks for the heat transfer per kg of steam. Because all the properties that we evaluate using the steam table are specific properties, that is per kg, per mass, per unit mass. So that's why he is asking heat transfer per kg of steam in cooling from 250 to 80 degrees. We have to find this out. We know that the first law of thermodynamics, Q is equal to W plus delta. And we know the formula for W is equal to PdV. When the volume is equal to constant, V is equal to constant, this will become 0. So Q is equal to U2 minus U1. Because delta U can be written as U2 minus U1. So what is the value of U2? U2 is the final state and U1 is the initial state. And what we have to do? We have to calculate. So U1 is nothing but at P1 is equal to 0.3 megapascal and T1 is equal to 250. This is my first state. So I go to the steam table because this is in superheated region. I go to the superheated steam table, and for this value, when I calculate what is the value of my U value is equal to, U value at this point is equal to 2729 kilojoules per kg, 0.0 kilojoules per kg. This is the value at state 1, and I need to calculate it for the state 2, which is the final state, which is U2 is equal to, at, we don't know what is my pressure, but what we know is, we know the temperature, so 80 degrees. I go to the steam temperature table and I write down what is my UF. UF is equal to, the UF value is equal to 334.96 kilojoules per kg, and my UG value is equal to, what is the UG value? 2481.5 kilojoules per kg. And we know that UFG is equal to UG minus UF. Therefore I subtract this from this. So 5 minus 334.96. The value that I get is UFG is equal to 2146.54 kilojoules per kg. And this is my UFG. So therefore U2 is nothing but UF plus X into UFG at state 80 degrees. So I'm going to put all these values. Therefore my U2 is equal to, U2 is equal to, what is the value of UF? UF is equal to 334.96 plus X value is 0.233. UFG value is 2146.54 will give me a value of U2 is equal to 835.10. 835.10. So this is my U2 kilojoules per kg. And we know that the heat transferred, heat per kg in Q is equal to, per kg means small letter, that's why I use small letter. Q is equal to U2 minus U1. Therefore is equal to 835.10 minus, what is the value here? This is about 2729.0, which gives me a value of minus 1890.9. The minus sign indicates the direction of the heat transfer. When I put minus, that means that the heat is taken out. So when heat is taken out, it is negative. And also when work is applied, it is negative. So when heat is taken out, it is going to be negative. And this is the answer for the third question, which is what is the heat transfer per kg of steam in cooling from this temperature to this temperature.